target by 2020, and you forget this 2020, it is very close. Now by 2030, we have to generate around 300 gigawatt of energy from the renewables, including the solar and wind energy systems. So mostly if you see out of this, at the present situation where we stand, as far as renewables are concerned, that is 87.02 gigawatt. This wind power is almost around 45.2% of total wind generation, the renewable power generation. And solar is around 29.54%, 54 gigawatt. So that is 36.7%. So this biomass is around 12.2%, and small hydropower is 4.6 gigawatt, and that is 5.7%. So what I'm trying to say that as far as the renewable energy is concerned, so India is also the leading agency in the world, and almost more or less third and fourth position in the solar and wind generation as far as the world is concerned. So this is a very good sign for all of us that we are not lagging as far as the renewable sources generation is concerned, renewable energy generation is concerned. But the point here is the concern is that how will speed up it? How does this technology will speed up very quickly in a quick manner so that we can catch the peak, and so that and then it will come to the saturation. So that we are in the below the saturation region. So therefore this slope, it should be very fast, and so that we can reach to the peak region. That is what is the target in Indian government target. So we all should come forward in this direction to participate in terms of like research or some industry built or some other curriculums. So therefore, this topic is very important nowadays. And the point comes why I started this next slide with this energy concept. Because if you do not know what is our energy demand and where we stand as the renewables energy concerned or coal-based energy is concerned, then we cannot think of like a new era like smart grid technology. Therefore, and this smart grid technology, the renewable sources basically play the great role. Because as you know, with the fossil fuel, our pollution level is increasing. Like carbon dioxide and carbon monoxide, those very poisonous gases are actually increasing, and the greenhouse effect gas is also increasing. So therefore, and there's an environmental concern. So and that is one concern. And second is, this fossil fuel based belt is existed. So we have to replace with the renewable sources. And these renewable sources are very intermittent in nature, very uncertain in nature. So to accommodate this uncertain and intermittent nature of resources, definitely the technology should be very, competent. And we cannot accommodate this kind of intermittent, uncertain, renewable type of resources just with the existing technology. The conventional technology may fail for that. So this is how the worldwide energy scenario stands. Like if you see, you can ask that there is a survey in the whole worldwide. We have one energy survey that where it is seen that mostly you can see here that by 2008 onwards, like here 2008 onwards up to 2029 or maybe 2030, so energy is increasing in an exponential manner. It's increasing. The demand is increasing in an exponential manner. So by 2030, this energy concept and this demand is going to be more or less 7,000 gigawatt in the worldwide. So this 7,000 gigawatt of energy you cannot expect to get from the coal-based generation. It is next to impossible. So therefore, these renewables are the alternate path, right? So this again, I said the key point that to integrate this renewable sources to the existing network, the existing conventional technology fails. That is what is the generation. That is what is our challenge stats and our research stats, our study stats and our investigation starts. So how to integrate such a huge amount of renewable sources to the existing network, right? And what are the consequences we are going to get? Like as far as the monitoring is concerned, production is concerned, stability is concerned, and of course, what kind of technology, like in the topology design part, controller design, then the inverter, in the renewable sources like solar, wind, the heart of those renewable sources are basically the converters, inverters, and of course the control strategy. So how to develop very good topology as far as the power tronics inverter converters are concerned. So many thought processes are there when this we are going to integrate the huge amount of energy, renewable energy sources to the existing network. So, and this is not only our thought process, this world energy scenario also prompts us that we have to very alert quickly, as quick as possible, to meet this increasing demand, and this demand is exponentially rising. And it is also researched that there is a forum which comes under this Smart Grid Investigation Forum, Global Smart Grid Federation Forum, and it is seen that the Asia, the continent, in the Asian continent, and mostly the India is having the developing country, and there the energy growth is tremendous, and the demand is tremendous, like exponential increase. So keeping all this in mind, we should be very careful next 20-30 years. So our energy trend should follow our demand. Our generation trend should follow, to meet our energy demand trend. Otherwise, you will be underutilized, or you will be overutilized, or it will be in the R-par, as the demand is going up. What is my suggestion and my question? We should meet the current trend of demand curve. So that is only is possible by this renewables. And already I have said with all of you that what is my motivation. When I was doing my research, and even now we are also moving ahead to the recent trends of this smart grid technology. So sometimes in my mind it comes, why we are doing such kind of research? What is the use of this? Even then some industry, they are also doing great research in this direction. What are the key points why we are so much interested? The first point comes to mind that we can reduce this carbon dioxide emission, reduction of global warming, peak energy deficient with renewable sources, and so on. And not only that, another motivation behind it is that it is not like that the solar and wind energies are not available in India. Yes, that concept is wrong. We have plenty availability of this wind and solar sites. And the solar sites we have, wind sites we have. So from where we can harness those energy for our utilization process. So another motivation, it was like recently also in Australia there was also one blackout 2016, and that was only for that due to some maloperation of the other devices. But here I'll talk about how a small protection device was maloperated, and it has led, it has created a tremendous loss to our country by July 2012, July 31st. Okay, so there was a line, 400 kV line, that was joining from Bina to Gwalior, that is a western to northern grid side top. So this 400 kV line was joining these two places, and that line was overloaded due to some reason, and because the overload drawing, there is an overload draw has been drawn from the northern side. So that line was overloaded, and due to that, what happened? One of the distance relay was maloperated, and because the zone 3, if somebody is from protection area, they can understand in better way. And just for your layman understanding, I can say like this: one of the protection device which was protecting this 400 kV line, that was maloperated due to the load encroachment problem. So what is this load encroachment problem? Means the load has been increased, loading of the line is increased. That is also dangerous. If any one of the relay settings are not proper, so that relay may maloperate. So you think about it. So a single distance relay maloperation like has laid towards billions of rupees of wastage of money, crores of money has been wasted, and many, when this line was tripped, what happened? Then then this disturbance, other lines become overloaded, and slowly those lines are tripped. And slowly this network was collapsed, and suddenly in the northern side the generators, basically mostly it is hydro-based generators, generating stations, and populated in the northern region, northern grid. So what happened? They're bound to shut down the generators. Okay, so because there is a mismatch in the electrical load and prime over mechanical input and electrical output. So this leads to PA, that is PA minus P, accelerating power, which may damage the stator as a rotor side of the generator. So they have to shut down it. So as a result, this northern grid and northeast, we have 5 national grids. So out of it, during this July 2012, this northern grid and northeast grid both are actually under blackout condition. So this is one of the biggest thought process, and after that, the Indian government has kept some task force for investigating for such kind of what are the reasons, origin of those disturbances, how it had happened. So to investigate all those issues, so the task force has been created, and it's found that it is very honestly speaking, and they got it the origin, and finally. Fortunately, we have resolved some issues, but still it is pending, and it is very essential to, before integrating large amount of renewable sources, we should avoid such kind of blackout. So for that, our protection, our control, our monitoring platform for such smart grid technologies should be very strong. Then only we can avoid such kind of blackouts. So this is how I have not, there are so many concepts that of the conventional grid, and somebody may ask, what are the demerits of the conventional grid so that we are going for smart grid? What is the reason why we are going for smart grid? What is the reason behind it? Isn't it? That will, of course, it will come to our mind. So this, this present grid, the conventional grid, we call it as conventional grid. There's a pressure. So this is actually the reality. This is not a very bookish knowledge or some IEEE paper survey. I'm not saying that. It is a reality, and there is a pressure on the existing grid or present grid. What are those pressures? The first one is the increasing grid size and complexity. Let me tell you that figure I have not kept here because we have to see more on the smart grid protection side. So therefore, I have not kept that figure. So increasing grid size means now that mostly in India or maybe in worldwide we have now AC grid, right? We don't have, earlier before 18th century, we have 1800th century, we have this, 1800 or 1865, 64 like that. DC grid was more prominent. Again, the same thought process is coming back. Maybe you don't know, after 10, 20 years, again we will be moving in the DC grid. But now it is not so much visible, it is in research phase. But AC grid is last 100 years, if you could see that it increase, if you can note down it even, if you put more effort, so the outcome from the AC grid and the long transmission line based AC grids, if you increase the size further, then the outcome is less. This thing we have to understand. That initial phase investment and the outcomes are fine. The middle phase, the size is further increasing, then the investment and outcome is fine. It is somehow optimized. But end of further if you increase the complexity size of the AC grid, you just make it so complex and so large in nature, and you just overload it, then your outcome will be very less. Now we will lose so many things. We are not in a good position to get what we have investigated. That means our input and output ratio will be very, very less. Efficiency will be very, very less. Output by input, that is efficiency. So it will be very less if the AC network structure increases. Now the question comes, why this AC structure, this is AC grid size will increase? Because our demand is increasing. Before a few minutes we discussed, our demand is increasing exponentially. So we have to meet it. Then if we are going to meet it, so we have to increase either the generation or we have to increase our infrastructure. So we have to do all this, isn't it? So therefore, this if we increase that side, what will happen, that in that case our resources has to be put in, but however the same output we may not get it from there. That is one need. Therefore, the present conventional grids needs desperately some flexibility in its structure, and that is what is the smart grid technology. So this is how the problems come from the conventional grid. As I said, increasing size, complexity, And you have, of course, demand growth. I said already, it is increasing exponentially. And the increasing energy trend, already we discussed, changing load flows, bulk power transmission. We cannot see with suppose one corridor is moving from Tehri, from northern side grid. I'm talking to you that we have here TSDC, Tehri hydro power plants, and from there they are generating Koteshwar and all. They are generating the power and they are pushing towards your Delhi Medak side. So through the 400 kV lines, double circuit lines, or 765 lines. So I mean, in that case, what happens? You cannot push more than beyond its capacity. That is for sure. So either you have to construct new corridors, you have to construct new erect new towers or lines, or you have to push with the existing platform. So which is very difficult for all of us. And you have this bottlenecks and overloads and variable in feet. And so finally, what I'm trying to say that is it possible to just have this kind of concept, remove this kind of mindset concept as quick as possible. That is what is my suggestion. Okay. So now, this microgrid actually, and the one smart grid or microgrid, I'll talk to you very soon, very quickly. I'm just going to that. Okay. So this drivers like why this flexibility is required, because we need a very efficient, reliable, and secure environment. So one more term I have not added here. We need a very sustainable environment as well. So why this sustainability comes to picture? Because if your network is efficient, it is reliable, secure, but however it is not sustainable in nature, then that is also not good. Because the sustainability comes to picture this dimension. There are 4 dimensions of this existing and the present smart grid technology. And the 4th dimension is the sustainable in nature. And why it is sustainable? Because due to the presence of renewable sources. And of course, you all of will be agreed with me. There is the till the point the earth is there, so wind will be there, sun will be there. Anyway, because this is our forecasting, our mentality. And of course, water will be there. So therefore, the renewable sources will add the 4th dimension to the smart grid technology, that is a sustainability. And this efficiency, reliability, and security comes with well-developed smart grid technology. You may ask me that whether this existing technology is not sustainable. No, not at all. It is not sustainable. And you don't think that this existing technology is efficient, reliable, secure? Yes, it is secure, but not that much. In US, Canada, Europe, their technology is 99.9% reliable. However, our network is just reverse. 9.99 reliability, you can say. That is my perception many times. Our system is, actually somebody may tell that, no, how you are saying that it is 9.99% reliable. Yes, because I have seen in the remote areas where the power cut is around 8 hours, 10 hours. Even I have seen some transformer is burnt, so the month they takes to repair it, replace it. So what is the meaning of that? You can say it is a 0% reliability system, power supply system. We cannot say that. Suppose I am sitting in IIT Roorkee campus, we have 24/7 power supply. That is not a good indication of the whole nation. The whole nation, when it is divided into urban cities, semi-urban cities, rural cities, and rural areas, so every area should be well equipped with the supply system. Somebody should not say that no, we are getting 24/7 power supply. What is the problem with the others? That is a very bad indication. So 70% of the people are more or less they are in a very privileged, and why not 30-40% people are not privileged for that? So therefore, this is the very point. So this developing country, developed nation concept will come to front when and only when 99%, 90%, 95% people will be privileged. I mean, they are well equipped with this facility. So this is how this flexibility can be brought, and we can avoid this such kind of problems which are existing in the present grid. Pressures, or you can say in other word, pressures on the present grid can be removed, or it can be overcome by using this smart grid technology and with the integration of renewable sources. So this is how the concept goes, like why this is important, and this is a. Now I'll talk to you what is the smart grid definition, and see this according to different acts and systems and laws and rules and regulations. In US, like they have some rules they have created, and they have some blackout in 2003, and after that they investigated that why this blackout was there over in the network, so they got so many losses. So after that they just found some layouts, some points they have developed after that, like increased use of digital controls, dynamic optimization, integrated distributed resources. Distributed resources means the solar systems and wind system, or some biomass or tidals or geothermal. By integrating those distributed resources, can you just overcome this sort kind of disturbances or blackout problems? And we should have very good demand response, smart metering facility, and also at our home, we have like 5 domains of customers. Like first domain of customer is we have the residential customers, the first customer, and the second category of customer is our agricultural customers, and the third category of customer is our big industrial belt, industrial customers, maybe small scale industry or large scale industry. And then we have our next one is commercial customers, commercial buildings. Okay, fourth. And the fifth one, actually previously we actually override, or we never talk about that customers. That is a transportation customer. So transportation is one of the loading system, because earlier we don't bother about the transportation part, because more or less you can see by the survey it is found that 20 to 30% losses are coming from the transportation sector. And now in the transportation sector, we are completely dependent on the diesel and petrol based engines, based cars, or four-wheeler, or the big and cars or vehicles like trucks and whatever, and two-wheelers. So now this concept is very soon it is going to be vehicle platform to the transportation sector. So this the India government is also alert in this regard. We have many pilot projects are sanctioned now all over the country. Somebody is doing some research on the developing some infrastructure, charging infrastructure of the electric vehicle. Somebody is getting some pilot projects for developing the charging stations, like the converters, inverters of the battery design, battery management systems, so on. So this kind of electric vehicle movement or kind of war is going to be seen next 10 years, and so that our the road will be populated, our transportation sector will be populated with the electric vehicles. So from there, those electric vehicles basically acts as a smart electric vehicle and smart appliances, and those appliances can act both as a load as well as the generator. Like while I'm taking to my office some electric vehicle, I'm parking from 9 to 12 or 1 o'clock. So that time, if there is any energy deficient or energy deficiency, the electric vehicle can supply those demand. And morning, suppose 6 to 9, suppose there is some energy availability, so I can go for charging of my electric vehicle. So this kind of thought process is coming in smart grid technology or smart grid area. And the smart appliances can do this only. If the appliances are not smart, so how can you just do these activities? That is what they aim. The US Department of Energy, they aim for develop as quick as possible smart appliances to overcome this crisis, or to overcome this such big large disturbances, and to overcome this kind of problems. And so, of course, should have some storage and peak savings. So storage should be there whenever we need some peak energy deficient. The storage should come to picture and mitigate the problems without taking more power or stressing the existing generator. We should access some other locations, other generating stations, or some resources from where we can also tap power during the peak energy period. And customer, this during this peak hour, what happens? Some agencies, they demand more. The cost of the power becomes more because they are delivering power at that time. At that crisis period means it's a great thought process, right? So they will demand more cost for that. So if you have some other resources, alternate resources like storage or some electric vehicle charging station, from there electric vehicle can also supply some power, or maybe some solar, some wind. So why should you go for why should you pay for more money for that period? Okay, so customer control, communication standards, reduce market barriers. So many things are there, but each topic is basically a very broad area. So I can give you some pictures of smart grid area. So that is what I'm trying to do. So this definition of this smart grid by 21st century, if somebody asks, so what could be the definition of this? What are the recent trends and developments as your topic, part B of your program? I was just reading when I joined this meeting that it's a recent trend towards this smart grid vision. So this smart grid definition we should know. What is a smart grid? So the smart grid is nothing. The smart grid refers to an electric transmission distribution system that incorporates the elements of, the first element of the smart grid is information technology. Second one is a communication technology. And third one is very important. I have not written here, so you can note down it. The intelligent sensors, intelligent, adaptive, dynamic sensors and controllers, automatic controllers. So when these three things are merged together, they are actually marrying itself. You can say one side you have the existing grid, and other side you have this information technology, ICT technology we call it as ICT, information communication technology. And so when these two things are merged together, so we just get a very good grid, and that grid is called as smart grid. So the smart grid is not, this Indian government is not going to separately build, no, this is actually smart grid and this is the conventional grid. We are going to renovate the conventional grid. We are going to make the conventional grid as the smart grid. Otherwise, just itself by separately making the smart grid network, it is next to impossible. So we are making the existing platform as smarter. So that is what, by integrating this renewable energy, battery storage systems, and adding this information communication infrastructure, and adding the intelligent sensor, adding the dynamic and robust, very accurate and this kind of adaptive controllers, automatic controllers to the existing network, basically is the term is nothing, that is the smart grid. There is no way to remember the things, but we are conceived that what is smart grid. This is the smart grid. The smart grid means if you are going to make some network smarter, so what are the requirements? And suddenly it will come to our mind. The first requirement is the very good dedicated communication infrastructure, information technology, like you have supercomputing facility, you have smart controllers, smart sensors, and of course you should have a very good dedicated controller, central controller or local controller. Okay. Now, as a result, our grid will be, with the presence of this, it will be intelligent in nature. So you don't think that the present grid is intelligent? It is intelligent. But what we need to this intelligent, what is the purpose of this intelligent grid if it is not serving our purpose? We do suppose in a charging station or some generating station, you have many intelligent sensors. But however, my goal is not fulfilled. What is our goal? Our goal is, here I have written, in order to efficiently deliver sustainable, economic, secure electric supplies. That is the definition of a global smart grid federation. As I said, you can just type this word, global smart grid federation, you will get so many information in front of you in the Google. So in this, all the countries, they participate and they set some rules and they set some regulatory commissions, and they develop some thought process. They survey and research and study statistics. Everything is done. In this forum, federation. So this. There is a indication which country is leading as far as the smart grid is concerned, or renewable sources are concerned, which agency is leading, which utility is doing better, the best, like that. So this efficiently deliver is, if it is not possible, even though my grid is intelligent or smart, there is no use. But at the same time, I should ensure that my smart grid should be able to efficiently deliver sustainable, economic, and secure electricity supply to the customers. Okay. So that is how another definition of smart grid. Here it is. The smart grid basically refers to a class of technology. Okay, it's using computer-based remote control and automation. And these systems are made possible by two-way communication technology. This is important. So earlier, let me tell you one story that my area, village, was located around more than 500 kilometers away from the generating station of NTPC Talcher. So when there was some outage, some problem at the NTPC, so our village was under shutdown or blackout condition. Why is it so? Why is it so? Because there is no communication between the customer and the generating utilities. That is the first point. There is no communication, data flow. So second point, and it is very far away from the customer site, isn't it? 500 kilometers is quite, even from Tehri to Delhi, I hope from Roorkee to Delhi, it is around 200 or some 200 kilometers, and Tehri another 200 or 300 you can add, like that. So we don't know what is happening at the Tehri station. So our thought process here in the smart grid is, why not? We are going to generate small chunks of power stations. Smaller, renewable energy source parks, like solar energy park, wind energy park, maybe hybrid wind and solar park, near to the customer end or near to customer premises. That leads to another technology called as microgrid. I'll talk to you after this. So this microgrid concept is basically the part of the smart grid concept, where previously this utilities, they think that we are the king and the customers are basically servant. If our things supply is okay, so we'll supply to the customer. Unidirectional power flow. The utilities will control the customers. Why not the customer is going to control the utilities? Why not the vice versa? This vice versa concept is only and only possible using this smart grid or microgrid technology. Okay. So and again, near to my just building or near to my village, I cannot set up a very big NTPC, national thermal power plant. Of course, that is not possible. But it is quite possible. I can have some 2 acres, 3 acres of land, and I can have a solar park. It is quite possible, and which is not also dangerous for the health, for humanity, environment. And small, like in the range of 10 kilowatt, a 10 megawatt scale of wind park, always I can do, isn't it? So this kind of thought processes came off only and only due to the presence of this smart grid technology, and of course with the availability of the renewable sources like solar and wind system. So that is what is my idea or opinion. As just I just want to inform to all of you that even though your system is very efficient, reliable, economic, but however, if it is not very sustainable in nature, even though it is very smart, what is the use of it? It is useless. So that should be our goals should be fulfilled. Okay. So let us move ahead. These are some characteristics of the smart grid because we have to move to our main topic, that is the smart grid protection So this is how the characteristics of the smart grid. If somebody, we understand what is, first I just want to clarify to all of you. First we understood that what is our energy stand, where we stand globally and in Indian scenario. Then I talk to you that what is the problem with the existing grid. Then I told to you why the smart grid is required and what is the definition. Then of course, knowing the smart grid, one child, a baby, what is its characteristic? It is more reliable, self-filling, self-monitoring, more secure, cleaner, support widespread distributed generation. Distributed generation means solar and wind, or you have biomass, fuel cell, small hydro power plants also considered as the distributed generation nowadays. Small hydro power plants. We have in India, we have a mission called as Small Hydro Power Plant Mission. You can visit one website, that is www.mnre.com. Ministry of New Renewable Energy Sources. That is a part of our parliament. That is a, I mean, it's a Sansad, or it's a statutory body, right? So there is a dedicated secretary, ministry affairs. So all they dedicate their time to develop the renewable progress in our country. In every state, the ministers they have, and very soon I heard, I don't know, but I am not so much political in nature, but I have released knowledge in as far as the politics is concerned. But we heard that in every state there will be a renewable energy ministry also, and to cooperate our central ministry affairs, okay, renewable energy ministry affairs, and that is necessary to update the progress. So in this front, this support widespread distributed generation helps customers better control of energy use in their homes and business, achieve higher throughput, and thus lowering the prices. Let me tell you one very interesting topic here. In US, I had a discussion with the Mission Innovation group of people from our country, India, that in US there is a card system, like you just purchase Geo card, Geo SIM, BSNL SIM, Airtel. So you just recharge your cards, right? So we just recharge. So similarly, in US, the customers now, it is a pilot project. Of course, it is not full-phased program. They are testing it. So this kind of thing, this they have a full-phased. It's not full-phased. That they can some customers, like they have card system. Morning 6 to 8, they can punch their card in some agency of supply where the power rate is less. Their cost per unit cost is less. Again, from 8 o'clock to 10 o'clock, they can reschedule their power consumption from another agency, utility, by punching their card, because there the cost is further less. So that means the customer has their own choice from which agency they are going to purchase the power. So this kind of independency, flexibility is only possible using this smart grid technology. Therefore, many times in many of my discussions in my class, teaching, or maybe some outside discussion, I say that smart grid is not a product or some service, like, we have some regulator. Okay, so take this regulator and it will regulate your voltage. Somebody will give you. Just you connect near to your stabilizer, near to your freeze or refrigerator and your some other appliances. It is not like that. Smart grid, actually, it's a vision. We have to work hard for this, to achieve this vision. And remember, this vision is not a static vision. This is a dynamic vision. As the technology is flexible and the technology is dynamic in nature, similarly, the vision should be also dynamic. At this moment, what vision I have, technology I have, it may change after 2 years, depending on the requirement, depending on the infrastructure, like this. So, this is how it moves, and depending on the utilities perspective, they see the smart grid in some other vision, and from the customer point of view, they see the vision is something else. Like in the customer perspective, like It should be very high operational efficient network. Multiple sources should increase in the reliability of the system. Reconfigurable network should increase resilience of the network. Self-healing should be there in the network. Automatic fault location first maintenance should be there, and demand management long-term savings should be there. So utilities will see its own perspective, isn't it? Through the smart grid technology. But where these perspectives are not necessarily equal for the what? Not necessarily equal to the perspective of the customer. So customer sees in the other direction. So what are the directions of the customer perspective? It should have some off-peak operation reduction in energy bills. Improve power quality, of course, because the customers need very well-defined power quality supply. Bidirectional interaction, increase in choices, and grid-connected local renewable generation, earning revenue, all this. Okay, so this is how the vision stands. So now I have given some thought process before, I think 5, 7, 8 minutes. What is microgrid? If you could just recall, I discussed few things about it. The supply to the near to the customer end is basically the concept of microgrid is generated from there. So instead of depending very long distance located centrally generating stations, so why not we will just my voice is clear to all of you, sir? Is it audible to all of you?
Yes, yes.
Yeah, fine. Thank you. So this this microgrid concept. What is the definition of microgrid? What is its definition? Tell me. What do you mean by this microgrid concept? You understand? Anybody can tell me, answer me this. What is this microgrid? Maybe during your research or your study or something like that. So any ideas if you have, can you just share with me, any one of you? What do you mean by this microgrid concept? Word itself. Anybody can answer me without any hesitation. And I'll be very happy if there will be a two-way communication, because as we are learning the smart grid technology, as I said, the smart grid technology is basically a two-way communication based technology. It's not a one-way communication technology, it's a two-way. So I need our communication should be two-way. At least for 1 hour I discussed with you very basic thought process with all of you. So slowly we are moving towards the inside technology, inside problems, and that will lead to the smart grid protection issues and areas. So anybody who wants to talk, like you can raise your hand or you can write in the chat box.
Dear participants, anybody interested to interact, just unmute your audio and direct connection of different loads.
Yeah. What do you mean by microgrid?
Interconnection of different
are you reading my PPT? No?
No, ma'am.
Good. Very good. So fine. Please go ahead.
Interconnection of different like solar, wind, and combination of battery, all those things.
Yeah. So anything is missing, sir, with your definition?
Fuel cells, all these things.
Yeah, that is fine. So integration of renewable sources and storages. Anything is missing in your definition? Anybody else? Thank you, sir. You are, to some extent, you are correct. So anybody else, can you just add something to this? So, right, no issue. So let me just tell to you nicely. So as I said, one of our participants, he said that integration of this renewable sources like solar, wind, fuel cell, batteries, storage system, battery. But the major things we should know here, what is this microgrid? Integration of these renewable sources and battery storage system to the existing grid. That is important. And this integration of those renewable sources and battery storage system to the existing grid can operate either in grid connected mode or it can operate in islanded mode. So now you may tell me why suddenly from this smart grid topic I jumped over to the microgrid, because I'll tell you finally again we will merge with the smart grid forum. Slowly.
Sorry for the disturbance. One participant mentioned in chat box, it's a group of interconnected loads and distributed energy resources. Was for the smart group of interconnected loads and distributed energy resources. One participant represented in chat box.
Yeah, that's good. Very good. Thank you for your participation, and this is nice to hear from all of you that most of you, the participants, are aware about it. I'm so happy for that, because I'm not telling that this is only one research area. No, this is a vital research area, I can say. And it's a very multidisciplinary research area. As I said in many forums also, the smart grid is not a one-man show. It is a show of multiple person. Like it needs the help of electrical engineers. The electrical engineering has many dimensions like power system, power electronics, control, instrumentation. So again, it needs the help of electronics. Communication is very essential. Information technology engineers, civil engineers, mechanical engineers, so everybody, the battery is an essential part of now this smart grid for storage and environment. So the chemical engineering, material engineering, and the physics engineering, so the physics department, they are also very a lot active in this direction. So let me tell you, it's not a single man show, it's a multi-man show. I mean, many people, they should come forward to help this. So I'm happy that many participants, they're knowing this concept to some extent. So coming to this microgrid concept, this microgrid basically it's a combination of interconnected renewable sources and storage, which are actually connected to the existing grid. And this existing grid and the storage and the battery, I mean this battery and the renewable sources can operate either in a grid connected mode or it can operate in an islanded mode. So if suppose the grid is absent, suppose, then also this renewable sources, storage and loads together, they can operate independently. And that mode of operation is known as islanded mode of operation. Okay, is it clear to all of you? So this, am I going fast? Is it okay to all of you, all the participants?
Yes,
can anybody? Yeah.
Yes, madam.
Yeah. So yeah. So this a combination of renewable sources, storage and loads. So you cannot say only the renewable sources, no storage. There is no storage means it is not a smart grid, it is not a microgrid, first of all. So there is a presence of renewable sources, there is presence of storage, there is a presence of loads, and when those are actually combined together and they are connected to the existing grid, it acts like a microgrid. And that microgrid can operate either in a grid connected mode or it can operate also in an islanded mode. Two ways of operation. Okay. Okay, so now the point here is this thing that the renewable, the microgrid is basically, the concept came when we are just going to remove the long transmission networks, because when we transmit power from a 2000 kilometers of line through a 2000 kilometer lines to a corresponding customer end, the losses are huge. So why not that power supply, energy supply are going to be available just near to the customer end. So it will reduce my losses. Okay, so that to achieve that concept, to remove that losses and achieve that small concept of small chunks of power supply, a solar park, wind park. Now the hybrid solar wind park is coming to picture. Why hybrid? Because let us say my solar, there is a rainy day So solar generation is 0, and then my wind system should be there to cope up. So this wind is also the beauty of the wind energy system is in the night time also, when the solar is off, the wind system will supply power. Wind you cannot stop. So this kind of small wind solar park or even single solar park will pump power to the nearest customers. So this concept is known as microgrid. So like this in a single district, if you have many microgrids, small microgrids together, and they're interconnected, so your district is getting the supply. And again, many districts, when they're getting supply, the whole state is fulfilled. And this, like this, many states are combined together, our nation is getting the power. So the small microgrids are basically the building blocks of the smart grid. When the many microgrids are connected together, they build the smart grid concept. So this is how this microgrid comes to picture quickly after my smart grid definition. So these are basically the microgrid is the cornerstone of the smart grid. Just we are going to build a building. What will happen? These buildings are the main. The bricks are the building blocks. Similarly, for the smart grid, the microgrid is the building block, isn't it? So this, what are the components of this major components of the microgrid? The first one is the energy supply. Already I said, distributed generation like solar, renewable sources, small combustion turbines. Next is the energy storage capacity like batteries, thermal storage. And we should have some demand response efficient measures, energy management system, and of course the grid. So all this together constitutes the microgrid environment. Now, one more terms here, I just want to tell you before that, what is the capacity of the microgrid? The capacity of microgrid is in the range of 50 megawatt. Now, let me tell you, we have a IEEE standard 1547 series. Like 1547.1, 0.2, 0.3, 0.4, like up to 0.9 or 10 something, you can check it in the Google. So there every interconnected connection rules, regulations are mentioned in those standards which are actually dedicated for the microgrid operation, design and operation. And it is seen that nowadays that this microgrid capacity also can go up to 100 megawatt also. And one more new things I just want to tell you. This micro means what? 10 to the power minus 6. And somebody will ask you, let us say I'll ask you, what is the capacity of a grid, national grid? How we can define the power? Somebody can answer me? If I'll just quickly tell you, what is the capacity of a national grid? Your answer will be what? Your answer will be quickly in the gigawatt. As I said from the starting of this lecture, I said the installed capacity of our grid is 300 something, I forgot. So that in the range of 300 gigawatt, the unit comes to be gigawatt. It is not only megawatt or kilowatt or watt. So gigawatt is when you have a very big grid system. But when this is a microgrid, what happens? The microwatt itself is 10 to the minus 6. So you multiply with 10 to the power 9 or your giga. So it will come down in the range of kilowatt. So micro name itself is, it is reducing the capacity of a grid, a small chunk of, small packets of loads and, isn't it? That is what is the microgrid means. So what is this mini grids means? In microgrid, the voltage level can be up to 11 kV, 33 kV. But in mini grids, the power level is up to 15 megawatt. Now, let me tell you, before this mini grid, in IIT Roorkee also, we have solar rooftops installed solar plants, like in the rooftop mounted solar energy system. our peak energy requirement is almost 8 megawatt, and more or less our average capacity, the utility capacity is around 6 to 7 megawatt, if I'm not wrong. So we are getting almost 2 megawatt, close to 1.6 or 8 from the solar rooftop mounted solar panels. But this acts as like microgrid, small microgrid, but honestly speaking, it is not microgrid because we don't have a storage facility. Now we got a project from Dist where we are going to install the storage devices at the sensitive points, and we should have very optimized environment. It is not there. Optimized and efficiently, we are not utilizing those energy. That is also one issue. So those kind of things will come up slowly if we'll do a very good research in this field. So, and this, what is this mini grid terms mean? The mini grid means the power range is up to 15 megawatt. In microgrid, it was up to 50 megawatt, and it is 15 megawatt. Okay. So this 15 megawatt mini grid range, the voltage level is up to 11 kV, and then we have small scale electricity generation up to 10 kilowatt to 10 megawatt. Fine. So I just want to have all of you just have a 5 minutes break, then I'll start. Is it okay, sir? Again, we'll continue up to 12 o'clock. Excuse me?
Yes, madam. Thank you, madam. You take for your 5 minutes break, madam.
Please take 5 to 6 minutes break and then you'll start because continuously...
Yes, madam. I am also planning to ask before that you told them it's time to take for 5 to 10 minutes to take them, madam. We'll start 11:20, madam.
Yes, sir. Please. Yes.
Okay, thank you, ma'am.
Okay, so welcome back to all of you. Sir, am I audible, sir? Yeah. Yeah, thank you.
Madam, further on time you share your PPT, madam.
Yeah, sure. Sure, I'm doing this. Can you stop your PPTs?
Yes.
Is it clear now? Is it visible?
Yes, ma'am. It is visible,
Yeah.
madam.
So, welcome back again. Thank you for your patience hearing. So, once again, we'll discuss about this smart grid or microgrid protection, and then we'll wind off. Okay. So, this after this microgrid, the term is mini grid. Fine. So, what is this mini grid term means? The mini is a further scaling down of power of the main grid. Okay. So, I said from the beginning that if somebody will ask me what is the power capacity of the Indian grid, I'll definitely tell it is in the range of gigawatt. So similarly, if somebody will ask me what is the rating of a microgrid, so further it will be reduced from gigawatt to megawatt, right? And further, somebody will tell me that what is this rating of a mini grid, so further it will reduce. It will come down again to kilowatt. Fine, is it clear to all of you? Now this mini grid power rating capacity ranges from 10 kilowatt to 100 megawatt. So means it varies from 10 kilowatt to 100 megawatt. So the main feature of this mini grid is it is actually it is not grid connected. It is a basically standalone system. So standalone means what? Standalone means the microgrid or mini grid which are not getting any supply from the conventional grid or conventional power supply. It is only empowered, or it is powered, it is getting the supply from the solar or wind or battery storage system. So this is how this mini grid looks like. You have solar, you have multi-level this inverter, and then you have storage, you have transformers, because this multifunctional inverter will scale up, it will just convert DC to AC. And from here, from the DC source, you can store some energy also, and this transformer will transfer the voltage level to higher level. Like if your multifunctional inverter is, let us say it is generating some 400 volt or something, we can go for 11 kV. Maybe 4.2 kV, something like that, isn't it? So next you have the agricultural loads, and you have some residential loads. In South Africa, I have seen that like small remote areas, remote villages, they have this kind of mini grid concept, where their villages, like 2-3 villages, they are equipped with such kind of mini grid facility. And they have the solar park near to 2-3 villages, and from there they are getting supply, at least power to the agricultural loads, because they don't have like commercial buildings, because they're not so advanced. They don't have any institutional buildings, some hospitals not so very close to them. So only those agricultural lands they can pump the power. And for lighting facility inside their residences, some other xeroxing facility and some printing facility, at least they can get supply from this solar panel, like this. So mini grid is a self-sustainable grid. And of course, I cannot say it is a 24/7 power supply is possible. Of course, if it is a rainy day, so there is a good chance of not getting supply. But if it is a good day, the sunny days, so they can get some supply during daytime as well as the night time with the storage facility. Is it clear? Now, moving ahead. So this nano grid is a further reduction in the power level. Nano means further 10 to minus 9. So further its power is reduced. It comes to the range of kilowatt and watt. So this nano grid is nothing, is a single building, you can say, as a nano grid. So like in the size of this nanogrid is less than 50 kilowatt. Okay, and this is actually a residential small commercial site building small mall or some IT buildings, you can say, like my building here, suppose we have 2 towers. We can have some rooftop installed solar panels, and from there we'll get some power supply. And this building can be called as a nanogrid. Okay. And now correlate your smart grid, microgrid, mini grid, nanogrid. As I said to all of you, beginning of microgrid, why suddenly I came to microgrid after the smart grid? Because the cornerstone of this smart grid is nothing, that is the nanogrid and this mini grid and further microgrid. So this is how the nanogrid looks like. You have loads, you have renewable sources, you have non-renewable source, means your conventional grid supply, storage, and then you have some gateway and some controller, central controller, and some there from the gateway you can communicate to the external world, external agency or entity, to whoever we like. And these are some of the key components of the nanogrid. We have the mesh time in the main grid or conventional supply. Here is the smart meter, and then you have the solar PV energy storage. From here you have inverters, and this storage needs a bidirectional converter because when it is required, this bidirectional converter will charge the battery, and this when it is power is required, the battery will discharge the power to the network. Therefore, near to the storage system, every time we have bidirectional converter. So from here we have again converters. Maybe you can convert to AC to DC. You have some AC loads, maybe you have DC loads. It is up to us. And finally, we have nanogrid controller, and this controller, you can see this red dotted lines, which are actually connecting to everyone, like it is controlling to the grid. It is a bidirectional information flow, and of course from the controller there is an information flow, data flow, no power flow. The power flows are basically mentioned here in the blue lines, and the information flows are in the red lines, okay, dotted lines. So this is how the microgrid made up of multiple nanogrids, many buildings. As I said already, we have discussed many nanogrids you combine together to make a final micro. Okay. So these are some of the segments of the microgrid. We have campus institutional microgrid, just like in IIT Roorkee. We have campus microgrid. We have military microgrids. We have community utility microgrid, remote off-grid microgrid, and commercial industrial microgrid. So honestly speaking, so these bells, if we combine together in our India, so total grid is the national grid, total smart grid. So now we are basically, we are just breaking off our national grid into small grids, and we are naming it into different conceptual names, like some campus institutional grids will be on one side, and military grids, microgrids will be on one side, and your commercial grid will be at one side, community grids, and remote off-grid. So I was discussing one of the army personnel that he said, in our army, we have very good, well-equipped military base, which are actually the emergency supplies, you can say, or our residences, you can say, our main office buildings, you can say, operators, theaters, places, you can say. We are empowering now through the solar. And for emergency process, we have kept diesel generators. Otherwise, mostly we are depending on the solar. So that's a good indication, right? So coming now to the very important part of this course curriculum, this discussion, protection of the converter-based smart grid. So what I said from the beginning, that when you are discussing either a conventional grid or a smart grid, doesn't matter. So its essential component or essential section, you can say, is the protection. So when we are taking the advantage, like you said that, or I said that microgrid has many good functionality, good features, smart grid has many good functionalities, features. But however, at the same time, there are many issues are coming up, isn't it? When you are going to integrate some uncertain reliable sources to the existing grid. So of course, we are going to also admit or take over be ready to solve those issues. When there is some advantage, there are some disadvantages. So this is not disadvantages, these are some issues we call. Technical term of this in research we call it as issues. So protection is one of the major issue in the smart grid. And again, out of protection there are many issues are there, and I'll take over here islanding issues. In IIT Roorkee, in our department, many students they are working with me. Somebody is working in the islanding detection issue. Somebody is working in the area of controller impact on the smart grid protection. Somebody is working in the area of restoration, like developing topologies of the inverter converter. So those areas we are covering, trying our best, but effectively next 5 years maybe some output, some contribution we can do to the scientific community. Okay, maybe some solution even we can hand over to the industry personnel also. These are some of the benchmarks, you can say, substandardized solutions for the industry. As we are in a progressive mode actually, so that's why we are doing it slowly. I mean, maybe after 10 years it will be a good solution for industry. So this is how already microgrid I have discussed. Now I'll explain to all of you what is the meaning of islanding. I just said it is very clear that many protection issues comes. So islanding is one of the major issue as far as the protection of the microgrid or smart grid is concerned. I'll explain you two things. You can even write by yourself if you are interested, somebody is interested in this area. I have seen many control people also work in this islanding detection. Many powertronics people, researchers, they also work. Power system people, they also work. Therefore, this is one of the important area I want to discuss so that many people, researchers will benefited. Okay. This islanding means when there is some fault in the main grid side. Okay. So what will happen? This breaker is going to be open. Otherwise, the disturbance will propagate. It will come to the microgrid area, and it may damage to my renewable sources like solar. I have inverters and some storage also. We have batteries. We have loads. So those equipment may be damaged. Why? Because when there is a fault, so this DGs and batteries also will try to contribute the current to the grid side also. So as a result, when this grid batteries, they are going to contribute some fault current. So this fault current may increase the level of its rating. So therefore, this switch should be quickly opened so that this main grid will be disconnected from the point of common coupling. I hope all of you know this word. The point of common coupling means where the first electrical contact the microgrid has with the main grid. And that point is known as PCC or point of common coupling. So these are some of the nonlinear loads and linear loads, unbalanced loads. This whole stock is known as microgrid. Now this main grid is off and microgrid is now disconnected. So this mode is known as islanding mode of operation. But you can write this islanding mode of operation maybe two types. One is intentional islanding mode of operation, and second one is unintentional mode of operation. What I discuss with you right now, it is unintentional. See, I don't know whether the fault is in the main grid or not. I don't know anything. So my circuit breaker is open automatically, and my microgrid is disconnected from the main grid. This is known as unintentional microgrid. Islanding operation. So in that case, the IEEE standard says that we have to shut down, or shut down is not an appropriate word because these are all inverter based. As I mentioned from my topic, protection of inverter based smart grid. So this is actually inverters, solar based, wind based, battery based system. So this inverter based renewable sources which are present in the microgrid should be de-energized, should be deactivated. More appropriate word will be here, deactivated. So how to deactivate these renewable sources with inverters? If it stop this solar system, The solar system has DC output and it converts DC to AC. So this gate IGBTs or GTOs which are present in this inverter, if I can stop the gate pulse to this, then it will stop powering to the network. Similarly here in the wind also in the battery. So now this operation should be, I should first detect whether the main grid is disconnected or not. Then I'll stop the switching pulse, otherwise no. So this way of doing this detection process is known as islanding detection. Understand all of you, I hope?
Yeah. Excuse me, madam.
Yeah, please.
Can you please make it full screen, madam?
Okay, I'm doing it. Is it fine now?
Yeah.
Ma'am, could you repeat once again?
Yeah, I'm just repeating. So now if you see, suppose this islanding detection means when the main grid has some fault here, and due to this fault or some disturbance, the switch is now static transfer switch. This is actually intelligent switch which is disconnected, and then this microgrid is disconnected from the main grid. Now, if it is disconnected, so what we have to do according to IEEE standard, we have to detect this scenario within 2 seconds, and we have to de-energize all the inverter-based renewable sources which are connected inside my microgrid. Now, how to de-energize it? We have to stop the gate pulse to this inverters. Okay. So once I know the detection, then only I will do this. Otherwise, without knowing the detection process, how can I do this? Therefore, there will be automatically one controller that is known as local controller, which will sense the voltage, current, impedance, whatever at this terminal of this DG. DG1, DG2. DG means distributed generation or generator, and DERs means these are all IEEE standard abbreviations. DER means distributed energy resources. Okay. So here at this terminal where they are connecting this bus, we will measure the V and I impedance and all power, so frequency, whatever you can say. So then from there we will come to know that whether these DGs are disconnected from the main grid or not, microgrid is disconnected from the main grid or not. This way of knowing the status is known as islanding detection. And then islandings are two types. One is intentional islanding, other one is the unintentional islanding. What is intentional islanding? Intentional islanding means, suppose, let me give you some example. When there was a blackout, I said in 2012 July, northern and northeast grid, that loads are disconnected from the main grid, and not disconnected, then knowingly they are islanded separately so that the disturbance will not propagate to those areas and they run independently. Understand? So this Delhi Metro, totally it was disconnected from the northern, because northern grid comes under, this Delhi comes under northern grid. So, and the Delhi Metro was completely disconnected, and your another one was your airport area, because which are very essential priority loads. Some hospitals, Fortis and other big, good group of hospitals, they are knowingly disconnected from the main grid and they get supply from the diesel generator setup backup. So this kind of islanding mode of operation of the small grids, microgrid, is known as intentionally islanded mode of operation. But today I'll talk to you on unintentional islanding mode. That is a separate, totally separate area. Intentional islanding detection process. Again, the intentional islanding is of two types. You can write it scheduled, unscheduled. Scheduled intentional islanding, unscheduled intentional islanding. That is separate. Maybe sometimes if we have some interaction, then we can discuss. So now I'll talk to all of you the unintentional islanding, because I don't know when the grid is off, my microgrid is disconnected, and I have to de-energize quickly this digits as quick as possible. So there are so many conventional passive. See, you can write that 4 conventional techniques are available. 4 conventional, passive island, the islanding, unintentional island detection techniques are there. The first one is the passive. Second one is the active. Third one is the hybrid. Hybrid means a combination of passive and active. And the fourth one is the communication. 4 techniques available in broadly. Okay. So, in passive island detection technique, conventional passive island detection technique, very common one is rate of change of frequency. You can see my slides, rate of change of frequency, phase jump detection, rate of change of power, rate of change of voltage. So these are some of the conventional islanding detection techniques. Now, you may ask me questions why research is going on still if these are available. But all these techniques, you can write, fails when there is a zero power mismatch condition. What is this zero power mismatch condition? Now your main grid is off. Now microgrid is disconnected. So inside this microgrid, it may happen that your generation is, let us say, high and your load demand is less. Or your load demand is high, generation is high. This is actually quite possible. So this change in the net change, delta P, delta Q, change in active power, reactive power mismatch. Basically, let us say the demand and generation, renewable source generation remains constant. So the change in delta P, delta Q is to be 0. This is known as zero power mismatch condition. So during this period, zero power mismatch condition, your the conventional, mostly the rate of change of frequency, rate of change of power, voltage fails, because it is obvious. When there is a delta P change, there is a change in voltage. When there is delta Q change, there is a change in frequency. So, but there is no change in delta P, delta Q. How the change in frequency voltage will appear? So, to overcome this, further techniques are developed, and more appropriate technique comes after this. And more or less, this passive island detection technique has one more demerit. The techniques are dependent on the threshold setting of the parameters. That also you can write. Now, to overcome this, there are so many active island detection techniques come forward. What is this active? Passive means, in case of passive island detection technique, we are measuring the voltage, current, impedance at the terminal of the DCs, renewable sources. And we are then further setting some threshold of the values like rate of change of frequency, voltage, impedance, power, and then we are taking the decision. But the demerit, I said that it fails during the zero power mismatch situation. Now, the active island detection technique helps for that. The active word itself means what? You can guess. Active means what? Active means we are playing or manipulating at the controller of the inverter of the renewable sources, like solar. We are doing some manipulating something at the controller of the inverter. That is why this name is active islanding detection. Which are active elements? See, out of resistance, inductor, capacitor, these are passive elements. But here your inverters, which are having the switches, electronic switches, those are known as what? Active elements. Isn't it? So if I can control those active elements or controllers, I can do something. The active elements will be control their operation. Something will happen. So from there I know whether the grid is off and on. That is what is the meaning of active element. One of the students, he has worked and we have published some good papers in IEEE journal. So therefore I'll discuss with you very shortly because there is no time. And you can read in the website, I have these papers. Frequency disturbance triggered the access current injection scheme for islanding. This active islandation technique. Okay. This paper is available in the website, or you can go for Google, you can download and you can read in detail. If you are really interested, you can contact me, give some feedback. So what is this? First of all, let me tell you, we have also many conventional active island detection techniques. But what is the demerit of those techniques? We found that those techniques are basically operating 24/7. See, the major demerit of active island detection technique is it is manipulating the controller of the inverter. Sure. So as a result, the frequency and voltage at the terminal of the DCs, they are going to be deviated from the nominal values, but not that much. But to some extent, it will be polluted because we are manipulating the control of the inverter. Because the inverter controller controls the voltage and frequency at the terminal of the DC. So as we are manipulating the control to some extent by adding some disturbance signal, so obviously my frequency and voltage is going to be little bit deviated from its own original value. This is known as power quality deviation. So, but what those techniques actually, they manipulate the controller 24/7. But in our case, what we are trying to do, if any disturbance comes, then only we manipulate. Otherwise, we know. So, to know the disturbance, we have kept one more extra parameters here that is known as frequency disturbance. Here you see, we mounted one FDR, frequency disturbance recorder, at the terminal of the solar panel. Okay, solar DC. Here one more FDR we mounted in the front of the grid, and we measured the voltage. FDR means it measures the frequency. Okay, so here FG means F grid, frequency of the grid is measured, and here the frequency of the DG means this distributed generators, this solar system is measured. The difference between these two frequencies, if it is exceeding some certain threshold, then we will inject some disturbance to the control of this inverter. This paper is published in IEEE Transactional Industrial Informatics. You can see this paper. It's a good paper. You can read and you can comment. So like this is the controller of the inverter, a DQ controller. So here the disturbance ID disturbance is injected to the controller side of ID section, and corresponding PWM pulses are generated, and it is given to the IGBTs of the inverter to control its operation, and further voltage and frequency are measured, and from here we have measured the disturbance impedance at the terminal of the DC, and we got some values. If it is exceeding some certain threshold, then we took the decision like this. Here you can see, when this frequency disturbance is exceeding my certain threshold value, then the injection of the current had happened. VD is measured here, and this IDS is measured here. So it is exceeding some certain threshold, so our trip signal is generated. And this side is non-islanding cases, because non-islanding cases also my technique should distinguish. Non-islanding means like load switching, like DG disconnection, line disconnection, some faults. So those are known as non-islanding cases. And islanding means only the grid disconnection. Okay, so this is second work also we reported very soon. This paper is accepted in IEEE Transactional Smart Grid. Here one more new addition we did. Disturbance current we have injected to the controller of the inverter. Here we have injected the disturbance reactive power, because this is more accurate when you have some loads which are actually resistive, inductive, capacitive in nature. And this one also, it is also acting well with the resistive loads, but here this technique works well for this scenario, and moreover this technique is more robust than the previous one. It covers more zero power mismatch conditions more accurately, less time. So here in place of FDR we placed micro PMU. The micro PMU, why we kept here micro PMU in place of FDR? Because we need some voltage current information, but the FDR only measures the frequency, not the voltage current. But however, this micro PMU measures voltage, current, frequency, everything. So this is actually a smaller version, the concept of the PMU. So then these two micro PMUs will interact with this PWM controller, and it will just do the needful for us what we need. So here is a controller, PQ controller, and here in this Q reference, Q disturbance is injected at the Q side of the controller, and the corresponding operation is done, and the PWM pulses are generated, and the required gate pulses are generated, and then just try to control the operation of the IGBTs which are present inside the inverter of the DGs, and accordingly it will stop the operation. So here we did like this. We have some parameters like frequency of the DC. It crosses the threshold, then the decision will be taken, and this injection of the reactive power will be there, and then the trip signal is going to be generated. So please go through this paper, but it is not possible here to discuss the whole detail things. Just I have given some percentage of ideas regarding this work. Even you can also do by yourself independently. Okay, so this now the very important point is when we are doing something, this kind of smart grid activities or research, we should validate those techniques through a HIL test bed. That is, HIL stands for hardware in loop test bed. So in our laboratory, why it is necessary? Because when I'm telling that this technique takes some 2 seconds, 1 second, how can you say that? Unless until we implement in a hardware platform, a real-time platform. Because real-time platform means just you clock. You see your watch, 1 second it is showing in the watch, the watch or your wall clock, wall hanging clock. Then, suppose your simulation is also taking 1 second, then it is correct. Because those techniques, if you are going to implement in the field, industry, then of course, if your wall clock matching real-time implementation is not verified, then those are not the valid techniques. If it's in the simulation platform, it is showing, suppose say 2 hours, 1 hour, but in real time it should take 1 second. So this is an invalid platform, right? So here in our laboratory we have RTDS, real-time digital simulator. We have this we have controller, DSP-based controller. Our algorithm runs here, and whole network configuration runs inside the real-time digital simulator RTDS. And from there, through this GTAO card, Giga transmit analog output card and Giga transmit an analog input card. So for this analog signal will come to the processor, again the decision will be going out into the input analog card. Sorry for the interruption. So now this GTAO card will just come the analog signal from the RTDS, and it will come to the processor. And this processor basically will take care of my techniques will run here, and then this will come to this GTA card inside this. And it will just open or gate pulse whatever I said to you. To just deactivate the DGs, and the corresponding decision will be taken. This whole process is known as HIL, hardware loop test bed. And we have also successfully taken one more laboratory recently, Dr. MP Vasne Smart Laboratory. And we have also one more lab, so the picture I have not kept here. So here you can see here we have the fuel cell base, and we have battery banks, and we have solar panels, we have wind system. So this is actual fuel cell. So all are connected here in this test bench. And we have processors also here, the battery banks down. These are the capacitors, inverters. So finally, it's a good lab, DC lab and AC lab both. So these are the things from my side. So any questions? So you people are most welcome to ask me the questions. Thank you so much for your patience hearing and giving me chance to interact with you people. Yes, questions please?
Yeah, thank you, madam.
Yeah.
The participant you have is unmute yourself and ask.
Or you can write in the chat box also if you are interested. You can write in the chat box. Basically, the chat box will not be available to me because I am not the organizer. So I believe. Yeah.
Hello, ma'am.
Please.
Ma'am, what is the IEEE standard rating for the microgrids, ma'am? Like in kilowatts or megawatts?
50 megawatt.
50 megawatt.
It can go up to 50 megawatt, starting from kilowatt to 50 megawatt. And voltage level up to 33 kV, mostly till date. As I said, it can also go to 100 megawatt sometimes, because now we are planning very large scale solar parks, like which can go up to also 100 megawatt also. That is also quite possible nowadays.
It can be used up to MB applications.
Yes, megawatt.
So as per my concern is, it can be used for the industrial sectors also.
Of course, why not? Because the maximum, you know the word captive power plant. The captive power plant means it is the individual own standalone captive, self-sustained captive power plants are available in every industry. when the main power cut is there, so they utilize the power from their own captive power plants, and those captive power plants of every industry are from the solar based.
Okay, okay, ma'am.
It's quite possible. Why not? That is what is our try. Our main goal is to have some good technology wherever the power is needed. But of course, in the form of packets, we can't go for gigawatt. Of course, therefore this name is microgrid. I said. So the microgrid is the cornerstone of the smart grid. You can have some small packets of power generating stations, and you can distribute the power. Is it okay?
Okay, ma'am. And also, apart from the wind and solar, why can't we use like a tidal and all, ma'am? We have a large
Possible. Honestly speaking,
is there in India.
It's a good question. It's a good question. Tidal energy, we have plentifully available tidal energy. It's quite possible, but at the same time, we have to see the feasibility. The first issue is the solar. See, at the rooftop of your home, suppose you ask to yourself, at the rooftop of your home, can you have the tidal energy quickly? Can you have?
No.
No, but you can have the solar energy quickly. Just keep one solar panel, let us say in the range of some kilowatt. As I said, in this is the nanogrid. Nanogrid works for a building particular tower. So in that case, just you tap the energy from your building, then utilize 2 fans, 2 tubes, and one refrigerator, something I can run. But the tidal energy, the concept is it is very cost effective and it is geographically concerned sites. So you cannot tap this energy. You have to have a very good generating station for that, and from there you have transfer to the nearby localities. Understand?
Okay.
And of course, through this you cannot transfer the tidal energy through the networks like infrastructure like towers, but you have to go through the cables, and cables are also costly. But at the same time, the tidal energy is hugely available in India because we have the 3 corners of our country covered by the ocean. That is a good source of energy. Is it fine?
Yes, ma'am. Is there any research is going on, ma'am, for the cost reduction on that tidal energy? It can be.
That is a good question, but that part I have not overlooking. Now my research is focused on wind and solar part.
Okay. Thank you.
Maybe in future we will do that, have a research on that.
Okay.
Thank you for asking the question and participating. Any further questions? Can you display those questions to me? And is there any ways out to display me so that I can read quickly and I can answer? No, I cannot see this chat box. That is what. So no, it is quite possible for us also. It becomes available. In my case, in my class also in IIT Roorkee, we took class through this only. I think it is not showing. It's maybe something you made this.
No, madam. Now you can just stop screen sharing, madam. This Teams window will appear to you.
Okay, so is it?
Now your video is appearing here.
Yeah.
Now you can be able to see the chat box, madam. All the participants.
I got. Yes, maybe it is coming up. Let me see. So. No, I can see only the participants raise a hand, more actions, that's all. I cannot see the chat box, honestly speaking.
No, in this hand raise, just after that, this chat box will be there. You can able to see this video and audio symbols, madam.
Yes, video audio symbol is there, and where is the chat box then?
Just hand raise is there, just beside that it is a chat box. Just click on that.
Hand raise?
Hand raise, just beside that hand raise.
It is not there. It is there, sir. Three dots are coming up.
Yeah, that is the participant. After 3 dots, right side, madam, right side.
Right side only. Yeah. Yeah, that's what I could see. Anyway, so please go ahead. You can ask me questions. What is the question? Okay, so cost analysis tools. No tools are available. See, this question you are asking from demand response side and pricing of the demand response side. So the demand response, DR, and demand side management. You can write these two words: demand side management, DMS, and demand response, DR. These two words are different. So these two are very upcoming research field also, apart from this protection, stability, control, whatever. So they are the pricing, setting the pricing of the corresponding signals, these DERs. And of course, it's a very good question. We have in our utility concept of view, in the view of the bureaucrats, I mean the regulatory system of Electricity Board of India, some rules regulations are already embedded. What could be the pricing of the solar and this wind? I said the MNRE side is there, new Minister of New Renewable Resources. They have set the cost for solar unit and wind unit, but still research is going on how to reduce those costs, even then further less. The solar cost has been reduced now. I heard 2 rupees. Okay, and it was earlier it was 6 and 7 rupees. We have reduced. How it is reduced? The government has not reduced. We have reduced by introducing some new technology, cheap technology. Just like in the solar, if I invest more, my cost will be the inverter and the panel will be more. So obviously I'll demand more cost from the utilities. But if I can use some good technology with less price, so obviously I'll demand accordingly. So therefore, this cost, which was earlier solar power cost was like 7 rupees, 8 rupees. Now it is 2 rupees per kilowatt hour, 1 unit. So this is only and only possible by using a very good technology. So that research we have to do. How efficiently I can do, that is what is the demand response technology and demand response management. Then only we can reduce the cost of this energy. And there is no such tools are available. As I said from one of my slides that smart grid is not a product or service, it is a vision. Time to time, depending on our requirement, we have to investigate and new technologies should come forward. And honestly speaking, we are far away from our destination. We are in the very progressing mode of 20% of our rising curve to saturation level. So 20% of that. So we have to reach beyond that. So research is going on and the technology is in a booming stage. And who knows, very quickly we will reach to the saturation level.
Madam, one more question related to same thing. Is the nanogrid and microgrid is economically viable? Do you think the price of the electricity will come down or increase?
Yes, of course, it will come down. That is why I said it is 2 rupees. Why it is possible? Because not only the price, see, always we cannot think in that direction cost-wise. Suppose you may tell me that this TV today, the TV television, people are using like 1 lakhs, 2 lakhs, 10 lakhs television. Why? If you have some money. Why they are using? They are not looking for the cost. That is for the safety point of view. Some good facility features, this blue light editing facility, whatever the other technical issues are there for eye and health and heart. So those issues also we have to be careful now, because now we are so much populated with the radiations and some technical affairs. So every time we should not see the cost. But of course, at the same time, we cannot make it more economically viable. I mean, we should make it more economically very cost effective, or we have to make it or in other word I can say it should be economically viable. Okay, so therefore this nanogrid and microgrid concept only and only came because to make the customers more comfortable, more flexible, and their participation is very important in the market. And in that way we can also reduce the transmission line cost. So instead of transmitting the power from a 2000 kilometers line center through a line, so where the land is an issue, political issues are there, political affairs is there, this tower cannot be built in this area, there is also geographical issues like hill stations are there, some river concept is there, forest concept is there. So many issues are there, maintenance issues are there. So to overcome this, therefore the microgrid concept has been developed. and this nanogrid concept has developed. The power is just near to that, and of course, due to that, so many issues are resolved. And the cost-wise, though it is to some extent, it is effective now, not reduced that much. But in near future, definitely we will beat it. As for example, you can see that the electric vehicles cost is like in the crores. Who will purchase it? Suppose I can purchase, suppose like a Honda Activa, 13 lakhs, 14 lakhs, 15 lakhs, 20 lakhs. So, but if it will be the electric vehicle will come in that range, so definitely I can purchase it. So that research is going on. I'm not saying that it is completely a successful project till date, but it is still in the pilot project mode. It is not implemented in the real network.
Thank you. Thank you.
Any participants, any questions from your side? I'll be very happy to answer. Or in fact, I am also learning from your side. You can give comments, and I request something is good, you take it home, take away to home, and bad things you can reject.
Yeah, not only doubts, you can also give feedback. Madam is asking that. Just speak 2 words. Anyone interested?
Yeah. So feedback, you can give good feedback, bad feedback, no matter. So you can improve it. So anything you like. So any questions, anything, you are most welcome.
Actually, many people are typing in the chat box, madam. Actually, it is an excellent session. Very much informative, but they can't able to speak now.
Sir. No issue. I'm really thankful to all the candidates. I have tried my best to put some information, and I always try in that way. If something goes wrong, so you can excuse me, and something good, you can take it, as I said from the before 2 minutes. And yes, of course, there is always a way to learn. Yes. We cannot say this learning is an endless process. And Einstein also says he has collected a sand particle from the ocean. So you think about us. So we are on the starting of our journey. So we are just searching our roadmap and where we'll land. And definitely, if you are so much confident and so much eager to accept the challenge, so definitely we'll reach our destination once, as for the smart grid technology is concerned, right?
Yeah. Thank you, madam. Yeah. Chandrababu, sir. Yeah. Sir, please. Yes.
Thank you so much, sir. Really, from my bottom of my heart, even I delivered lectures in many places, but honestly speaking, I felt very much, I felt honored being in association with all of you. And really, I cherish this moment. How these 2 hours passed, I don't know. So, but really, you people encouraged me to speak something. Very small portion of the smart grid. It's a very vast field, ocean-like thing, you can say. So I just tried my best. So in future, I'll try my best to, if I'll get some opportunity to talk, then I'll share more about it. So thank you so much, Saravanan sir, and your HOD and organizers, and giving me this opportunity. See, I'm thankful to you people. This kind of opportunity everybody doesn't get, but I got it. So I'm happy. You called me, you invited me. I'm really happy. And I'll put my best effort in future.
Sure,
Yeah.
madam. Sure, madam. Thank you, madam. Once again, madam. Once again, I thank you on behalf of the program coordinator.
Yeah.
I sent the mail immediately. You accept our invitation also, and
Yeah.
it's give a wonderful lecture to our participants. Our another one, our faculty members also. Many faculty members are enjoyed your lecture. Thank you once again. You just to give the difference between mini grid, microgrid, and smart grid. It's having very nicely explained each and everything.
Sir,
It looks
sir.
like students. Thank you once again, madam, on behalf of
Thank
our
you.
DVR. Thank you.
Thank you so much, sir. Thank you. I need your motivation like this and to move ahead in my life. Yeah.
Thank
To
you,
do
ma'am.
good research in this direction. Thank you so much. So I can quit now, sir, with your
Yes, yes,
permission.
madam. Yes, madam.
Yeah. Thank you so much. Thanks to all the participants for patience hearing. Thank you so much.
Dear participants, already this feedback form posted in this chat box as well as the WhatsApp group. Try to complete within 1 hour. To 1 o'clock, I will disable this feedback link. It's another one. This next session will start on 1:30 p.m. today. So all are get connected with 1:25 p.m. Thank you, participants.